Alright guys, we are closing out this unit on parabolas and circles by now looking to be able to write the standard equation of a circle. Real similar to the process that we used when we did parabolas. We're going to use a completing the square process to complete the square in order to create this standard equation of a circle. So a quick reminder on what that looks like. So as we've been looking at so far, this is what the standard equation of a circle looks like. So we got x minus h squared plus y minus k squared equals r squared. So if you guys remember the similar issue we dealt with in parabolas, we have a quantity squared. But the difference with circles, and the reason we did parabolas first, is that the thing that's a little tougher with circles is you now have two of them rather than one of them. So with the parabola, you only had one quantity squared. With the circle, you now have two quantities squared, so we actually have to do a completing the square process twice in order to get this into standard form. So this is what we're shooting for. Just as a quick reminder on the process that we use with parabolas. Remember that the reason we have a quantity squared is because if you were to take a perfect square trinomial, this was an example that we used in a previous lesson, but this is a perfect square because if you were to try to factor it, like if we said what are numbers that multiply to be 9 that add to be 6, they would be the same, right? It's the same number. It's 3 times 3. So that's what makes this a perfect square. So as we were to write those, we would say, well, then my factors are x plus 3 and x plus 3. And when they're the same factor like these guys are, then we can combine them to look like this. And then that's where we get the statement of something like x plus 3 squared. Right? And so this is what we're shooting for. So we're looking at this process to put things into this form so that we can get that standard equation of a circle. So let's take a look. We're going to be given equations like this that are more in a general form. And we have to sort of rework it to get that standard form. So a couple things I want you to notice about this. Our first step in the process is to group the x's together here. We're going to group the y's together here, and this is going to be our constant, or any number that doesn't have a letter attached to it. Right? So that's kind of the first way we're going to organize it into that format. So let's start by just putting the x's together. So I have an x squared plus 16x. Then I'm going to group my y values. So I have a positive y squared. And I'm going to leave a little room for myself so that we can complete the square in a moment. We have a minus 22y. And again, we want to get the constant on the other side. So I'm going to add 40 over to here. So there's just kind of our first step, which is just organizing things where we need them to go. Now we're going to complete the square, and if you remember the little formula that we used to complete the square looked like this. So remember, when you look at a trinomial, something with 3 terms, your a value is always in front of x squared, your b value is always in front of x, and your c value is always your constant. Right? It's the one that doesn't have a letter attached to it. So when we write this formula, what we're saying is, look at the x's for a minute. This is my a, this is my b. We're missing our c value. So this little formula helps us figure out what our c value needs to be in order to complete the square and create this perfect square. So we're going to take our b value, which is 16. We're going to cut it in half, so that would become 8. And then I'm going to square it. So it becomes 64. So that tells me I need to add 64. And now this will be a perfect square. One thing you cannot forget to do, though, is if you're going to add 64 to the left side of your equation, then you got to add 64 to the right side as well. So let's do the same thing with our y values. So again, I'm going to take my b value, negative 22. I'm going to cut it in half. It becomes negative 11 squared is 121. And again, if that's what I'm going to add to the left, I also need to add that to the right. All right, so we've now completed the square. We've just got to put things in the right form. If you were going to factor this, two numbers that multiply to be 64, that would add to be 16, would be 8 and 8. And again, they're going to be the same. That's why this is a perfect square. So we would write these factors as x plus 8, x plus 8, which, as we just talked about up above, can be written as x plus 8 squared. Let's do the same thing for this one. Numbers that multiply to be 121, that would add to be negative 22. And again, they got to be the same. So it's going to be negative 11, negative 11. So we're going to write that as y minus 11 squared. And let's just clean up the right side here. So if I add all that stuff together, 64 plus 121 would be 185, plus this makes it 225. And that's it. So that would be the standard equation of this circle. Just as a quick review, remember what you would do from here if you were asked some specifics about it, or if you were being asked to graph it, is we would say, well, what's our center? Based on these numbers, it would be negative 8, positive 11. That's the center of this graph. What's the radius? Remember, this represents the radius squared. So I need to square root that to figure out the radius. The square root of 225 is 15. So if we were to graph this one, this would be the center point, and I would move 15 units in all directions. If you're going to do that with numbers this big, remember it's probably best to count by 2s or even 3s if you need to. With a radius that big, we might even count by 3s. Of course, these aren't the friendliest numbers if you're counting by 3s. We're going to be in between points if we do that. So those are not like the prettiest ones to graph, but let's give it a shot just so that we can review our graphing process. If my center is at negative 8 and then up 11, that means it's going to be way up here. So I'm going to put my axes way to the right. So I'm going to make this my y-axis. I'm going to put my x-axis way down here. So here's the x-axis. So our center, let's see if we can get away with just counting by 2s here. I think that'll be okay. So if I go negative 8, so let's say 2, 4, 6, 8, and then up 11, so 2, 4, 6, 8, 10, and then 11 is going to put me in that halfway mark. So there's the center of our circle. And with a radius of 15, then we got to branch out 15 units from here in every direction. This is still going to put me off the grid, but that's okay. We're just going to ballpark this as best as we can here. So 15, so I'm going to go up 15 units. So remember, that's really, if I cut this in half because I'm counting by 2s, that means I need to go 7.5 units up, right? 7.5 in every direction, right? So there's my half. 1, 2, 3, 4, 5, 6, 7. So that would be 15 units up. There's my half. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.5 is going to put me about here. And then 1, 2, 3, 4, 5, 6, 7.5. So pretty close. I tried to get it all on the grid, almost. So anyway. So maybe this would have been a good one to count by 3s. It's just tough to count by 3s when you're not dealing with multiples of 3 in those numbers. Guys, if you ever don't count by 1s, always good to note what you counted by. So again, you can label that on your grid somewhere. Like maybe you would put a little 2 right here and a little 2 right here. So that tells whoever's looking at it that you're counting by 2s. Or you can just state it. But it's always good to make note of that, so that way we know that you counted correctly. I'm going to do one more with you, and then I'm going to leave the last 2 for you to do on your own. So I'm going to do number 1, and then I'm going to give you a hint on number 3 to help you get started, because that one's just a slight difference at the beginning of it. But anyway, let's look at number 1 together. So again, the first thing I want to do is put things in a proper order, right? I want to get my x's all together first. So I got the x squared minus 16x. I'm going to leave a space, and then I'm going to put my y value. So I had a positive y squared. And on the other side, I would want my constant. If you look at this one, though, I don't have any constants over here. So I can just leave that at 0 for now. So let's just start with the x's for a minute. Similar to the last one that we did, my b value is 16. So remember, this is the formula we're using to complete the square. So if I put my negative 16 in there, I get negative 8 squared, which is 64. So I'm going to add 64 to both sides. Don't forget to do that. That's important. Whatever you do to the left, you got to do to the right. So what about that y value? Notice it's just y squared. There's no b value. So what do we do with that if there's no b value? Well, if you just think of it in terms of the formula for a minute, if I put a 0 right there because there's no b value, well, 0 divided by 2 is still 0, and 0 squared is still 0. So what they're telling me is it's already a perfect square. I don't need to add anything to this. Okay, it's already a perfect square. So in other words, if you just get like an x squared or just a y squared and there's no b term, then just leave it. It's already a perfect square. As we saw in the past, that simply means the coordinate at that point is 0. And so there's no plus or minus attached to it. So that's it. This guy's already done. Let's get this guy into the proper form. So if we said products of 64 that would add to be negative 16, should be negative 8 and negative 8. So we would write this as x minus 8 squared. Then I got my y squared. Over here I just have my 64. And that's it. So that would be the standard equation of the circle. If we did want to graph it, then remember this means our center would be at positive 8. And again, since there's no number here, our y-coordinate is 0. And if you square root this, it tells you that the radius is 8. So this will be an easy one to, we could count by 1s or 2s on this one, to be honest. So whatever you decide to do, again, if you don't count by 1s, just need to make note of it. So we're going to graph this guy. Let's see, this one's going to go right 8. So I'm going to push my y-axis to the left. I'm going to put that right here. Put the x-axis right in the middle. So if I go right 8, so I could fit this on the grid. Let's just count by 1 since it will fit if I count by 1s. Actually, it won't fit up and down, will it? So let's count by 2s. So I'll just make note of that. So this is a 2, and this is a 2. So that, again, that tells anyone looking at this that I'm counting by 2s on both axes. So we're going to go to 8, 0. So 2, 4, 6, 8. And then I need to go 8 units in all directions. So 2, 4, 6, 8. 2, 4, 6, 8. It's me right there on 0, 0. So there's the outline, connect the dots. And there's our circle. So that's what you guys are going to do for the next 2. You need to put them in the right form, identify these 2 key pieces of information, and then make a graph out of them. So let me give you a quick heads up on number 3. So number 3 is a little different because they started with a couple guys on the right side. So what would we do with that? Well, first of all, let's move what we need to the left side. Remember, we want the constant on the right. So he's already where we want him to be. All we really need to move is this. So we're going to add x squared to both sides in order to move it over to here. And then right behind that, I'm going to put my 8x. And then I'm going to put the y value. So I have a positive y squared. I got a 32y. And on this side, we already have our constant. And now things are grouped and kind of placed in a proper order. Now you can go ahead and complete the square and finish that process and graph it. But that is it for this one.